choice, elimination or substitution. Okay. Let's move on to today's lesson. Lesson 3, and this is geometric sequences. So we'll learn about what geometric sequences are, how can you find the general term in a geometric series, just like how we did in arithmetic sequences. So let's look at what geometric sequences are. So the first question that you see over here, what is the pattern that's being followed? It's getting multiplied by 2 every time, right? Because 2 times 3 is 6, 6 times 2 is 12, right? So when it's being multiplied by 2, that is an example of a geometric series. Okay? What's Yes. Yes. So when it's adding or subtracting, it's going to be arithmetic, A for adding, A for arithmetic. Geometric is going to be multiplied or divided. So when we look at the next pattern, what is the pattern that's being followed here? Adding 3, this time it's adding 5, then it's adding 7, and then it's adding 9. 25 minus 16 is 9. So that's not geometric. Now we have 8, 4, 2, 1 half. What's happening? Divided by 2 or being multiplied by half. Right? So that's another example of a geometric series. Okay? So a geometric series, the ratio between the consecutive terms is constant. Even in arithmetic series, the ratio or the difference is constant. So we have ratio in geometric series and difference in arithmetic. And this ratio is called the common ratio. For arithmetic differences, it was called common differences. The common ratio R can be found by dividing a term by the previous number. Previous number or term in the sequence. Okay? So the common ratio is going to be Tn over Tn minus 1. So the current term divided by the previous term. Okay? Let's look at what it'll look like in terms of when we're writing all the general terms in the geometric series. Okay? So T1 is T1, T2 is going to be T1 times R, T3 is going to be T2 times R, or T1 times R times R, right? Because T2 is T1 times R. So T4 is going to be T1 times R times R times R. T5 is T1 times R times R times R. And Tn, any guesses what Tn will be? T1 times R. Okay, the way we can figure it out is when we have T1, we don't have anything on R, right? Like R is to the power of 0. 2, the power is 1. 3, there are 2 R's, so it'll be R squared. 4, it's going to be R cubed. 5 is R4, so it'll be n minus 1. Because potentially 4 is just 5 minus 1. 3 is 4 minus 1. So that is the formula that we'll use to figure out the general terms. Okay? And it'll be given to you in the formula sheet. So T1 is your first term, n is number of terms. R is your common ratio. And these are the main terms. Any questions or confusions about geometric series or sequences, sorry? Yeah. Okay. Let's look at how we can solve a question that involves geometric series. A biology student is studying the growth of a strain of moss by observing the change in its weight every day. The table below shows the mass of the moss in grams at 12 noon on each of the first 4 days. So we need to figure out if the moss will form a geometric sequence or not. That's what you do every time you have a word problem. Check if it has a common ratio or a common difference. Okay, so because if I think of, okay, let's say it's arithmetic, it's going to add by 4, and then if I add by 4, I'll get 16, not 18. So it's not arithmetic, right? It's being times by 1.5, and the way you can figure it out is, remember, ratio is just Tn over Tn minus 1. So we can take term 2, which is 12, and term 1, which is 8. 12 divided by 8 in your calculator is just 1.5. So that's your common ratio, and it is a geometric sequence. Okay. Determine the general term formula that relates to the number of days to mass of the moss. So we know the formula is Tn is equal to T1 times R to the power of n minus 1, right? T1 is 8, so I'm going to put 8 times, this is the ratio 1.5, n minus 1. So this is what my formula would be to figure out the general term. Determine the mass of the moss on 18th day. 18th day is going to be our n is 18, so it'll be T18 is equal to T1, or we can just put it in the formula over here, is equal to 8 times 1.5 to the power of 8 minus 1, which is 8 times 1.5 to the power of 7. Plug that into your calculator, and you should get 7,882 grams. That's good. Questions? Okay, the second type of problem that you might get is if you want to figure out a particular term. It's kind of like what we just did over here. Figure out a particular term, right? Sometimes you use a photocopier to create enlargements or reductions. Suppose the actual length of the photograph is 25 centimeter and the smallest size of the copier can make it to 67% of the original. What is the shortest possible length of the photograph after 5 reductions? Will 25 centimeter be? The actual length of the photograph is T1, so it would be 25 centimeters. 67% would be our ratio. So 67% as a decimal, it will be 0.67. And after the reductions, after 5 reductions would be, what number of reductions are we doing next after 5? 6th. So we are trying to figure out what T6 is. The keyword here is after 5. Okay, so what will the size of the photograph be after it's being reduced 5 times? So we'll just put it in our formula. T6 is going to be T1 times ratio, which is 0.67, to our number minus 1, so 6 minus 1. So we have 25 times 0.67 to the power of 5, which will be 3.4 centimeters. Okay. Let's look at the third type of question. These are the questions you guys have been struggling on when it comes to arithmetic series or sequences as well. So you need to find T1 and R this time. You're given the third term is 54 and term 6 is negative 1458. So there are two ways you could do this question. T3 is given to you as 54, which means if we use the general formula, it's going to be T1 ratio 3 minus 1, which is T1 ratio squared. So that's equal to 54. Okay, that's my first equation. T6 is going to be negative 1458, which is T1 to the power of T1 r to the power of 6 minus 1, which is T1 r to the power of 5 is equal to negative 1458. Okay, so that's my second equation. Now I can not subtract or add this, but I could divide both the equations from each other, right? So I could do 2 divided by 1, which would give me T1 r to the power of 5 divided by T1 r to the power of 2 is equal to negative 1458 over 54. Any questions about how I got the division piece? Okay. And the reason why it works is T1 divided by T1 is just 1. R to the power of 5 over R to the power of 2 is R to the power of 3, and negative 1458 divided by 54 is negative 27. So to isolate my R, now I need to do cube root both sides. R cube to the cube root is just R, and cube root of negative 27 is? That's okay. So we have cube root, right? Or we can just do this as bracket starts negative 27 to the power of 1 over 3, right? Because that's cube root and that's negative 3. So R is negative 3. And now that I have R, I can just plug that in to my first equation, right? Which will give me T1 is times negative 3 to the power of 2 is equal to 54. 9 times T1 is equal to 54. Divide both sides by 9, and I get T1 is equal to 54 over 9, which is 6. So I got my T1 and the value of R, which was part 1. Now to figure out the first 6 terms, all I need to do is multiply 6 with negative 3. So 6 times negative 3 is negative 18, times negative 3 is 54, times negative 3 is negative 162, times negative 3 is 486, times negative 3 is 1458. Okay. If this were an arithmetic series, we'll have to add it, but because it's geometric, we'll be multiplying it. can just take term 3 as term 1, and third term and the sixth term are 4 terms apart. So it'll be T4, right? Because T1, so 3, 4, 5, 6, right? This will be 1, 2, 3, 4. So term 1 and term 4. We can just assume that it's term 1 and term 4. So T1 is equal to 54, right? And T4 will be T1 r to the power of 4 minus 1, which is, we know our term 4 is this, negative 1458 is equal to 54 times r to the power of 3. Divide both sides by 54. 54 divided by 54 is 1. Negative 1458 divided by 54 is negative 27, which is r cubed. So we are basically at this step, right? And we didn't have to do all this. We could have just shortened it up. And either way works. So we'll do cube root both sides. R is equal to negative 3. And then once you have negative 3, you do the same thing to get T1. And then the number of terms in the series. Make sense? Questions, confusions? Okay, let's move on to the last type of question that you will have from geometric series. Is when you have to find the number of terms. So figure out what n is, okay? So we're given a series. We have T1, we have Tn. Is this a finite series or infinite? Finite. It stops, exactly. So we have Tn and we have T1. What will our ratio be? 2, it's being multiplied by 2. If you're not sure, you can also do 6 divided by 2, which is, 6 divided by 3. 6 is our second term divided by our first term, which will give us 2. So we have everything. All we need to do is write down the formula. Tn is equal to T1 r to the power of n minus 1, right? We don't know what our n is. However, we do know everything else. Tn is 768, T1 is 3, ratio is 2, n to the power of 1. Now I'm going to isolate my n. So to isolate my n, I'll divide both sides by 3. 3 divided by 3 is 1. 768 divided by 3 is 256. So 256 is equal to 2 to the power of n minus 1. Now this is grade 10, right? Because you have an exponent where you don't know what the exponent is. What will you do to figure out what n is? Make the bases the same, right? And the powers will be equal, exponent laws. So 256 can be written as 2 to the power of close 8. 2 to the power of n minus 1. Now that bases are same, powers will be equal. So that means 8 is equal to n minus 1. Add 1 on both sides and we get n is equal to 9. Okay? Questions? That's it, you guys. There are 4 types of questions that can come from this on your test for this lesson. Try doing the your turn questions. You have the whole block to complete that, so you should be good. The answer keys over here as well. I have posted the homework pages on Google Classroom, but if you want me to tell you, it's pages 26 to 31, question 1 to 5, 7 to 8, 11 to 13, and 15. Okay, So do the your turn questions first and then do the practice questions or the homework questions.